Well, hello, everybody. As you can tell, my voice is going away, but I'm going to try to make this video, so I'll apologize right now if this is hard to understand. But we'll fight through. All right, here is your lesson summary video for our Completing the Square Part 3 that we did in class today. In earlier lessons, we worked with perfect squares, such as x plus 1 squared. That's a perfect square. We also saw examples like x minus 5 times x minus 5. You are multiplying something by itself. That is a perfect square. We learned that their equivalent expression in standard form follow a predictable pattern. So in general, let's switch colors. X plus m squared can be written as x squared plus 2 times m times x plus m squared. So when you have a perfect square in factored form, the first term in standard form is this term squared. So you square the x, you get x squared. The last term is this term squared. M squared is m squared. Then, if you multiply x times m together and then multiply it by 2, that's always going to be your middle term. So that's why it's a 2 times m times x. All right, if a quadratic expression is of the form ax squared plus bx plus c, and the value of x is 1, then the value of b is 2m, and the value of c is m squared for some value of m. So that's just showing the pattern we've been working with. So what made today's lesson different is the variable in the factors being squared had a coefficient other than 1. For example, instead of just an x, maybe it was a 3x plus 1 squared. That's a perfect square. Or 2x minus 5 times 2x minus 5. That's a perfect square. Their equivalent expressions in standard form also follow the same pattern we saw earlier. So let me just point out what the pattern is. Here we have the 3x plus 1 squared. So the first term in standard form will be squaring the 3x. So 3x squared is 9x squared. The last term is squaring the second term here, so 1 squared is 1. Now, if you multiply 3x times 1 and then multiply it by 2, that's how we get this 6x. So 3x times 1 is 3x, times 2 is 6x. Their standard form. So just to look at another example to make sure we're understanding, here we have 2x minus 5 squared. The first term in standard form is squaring the first term in here. 2x squared is 4x squared. The last term is squaring the second term. A negative 5 squared is a positive 25. To get that middle term, you take 2x times negative 5. So there's the 2x times the negative 5. And then we multiply it by 2. We're getting that negative 20x. So in general, kx plus m squared can be written as, so the first term squared plus 2 times the first term times the second term plus the second term squared. Or if we multiply that out, kx squared is k squared x squared plus, if we multiply that second term out, we get 2kmx plus m squared. So how does that relate to the a, b, and c values that we know of ax squared plus bx plus c? Actually, maybe we'll write it right below. Ax squared plus bx plus c. So when we write it right below it, what we can see is that the value of a is k squared. The value of b is this 2km. And the value of c is m squared. All right, so we can use this pattern to help us complete the square and solve equations when the squared term x squared has a coefficient other than 1. So here we have, for example, 16x squared plus 40x equals 11. What constant term c can we add to make the expression to the left of the equal sign a perfect square? I'm actually going to go off script here a little bit, and I'm just going to jump to the bottom and talk through this the way that I would have talked to you about this in class today. So to complete the square, we need to add in a c value. So we have 16x squared plus 40x. We need to add something in to complete the square. So what you want to think about is that 16x squared, what are you squaring to get that? A 4x. So we're going to remember that this middle term is made up of the product of three things. It's 2 times, it's always a 2, whatever you square to get the first term, which is 4x, and then whatever you're squaring to get the last term, which we don't know. So we're going to think through what that number should be. So what we know is that 40x is equal to 2 times 4x times something. 2 times 4x is 8x. 8x times what value gets us 40? And we know that 8x times 5 gets us 40x. So the c value that we add in is this guy squared, so plus 25. And then let's make sure we add in a 25 to the other side. So where I'm hoping this is helpful is to write this as a perfect square in factored form. We've got the terms we need right there. Not the 2, but the 4x and the positive 5. 4x plus 5 squared is how that would look in factored form. Equals, go ahead and add the 11 plus 25 and get 36. Now we have a perfect square equal to a perfect square. So we're going to write our two equations. So here we're squaring something to get a 6. What can you square to get 6s? I'm sorry, 36. My brain's jumping ahead. We know that we're going to set that equal to a positive 6 and a negative 6, and then we just solve. We got x equal 1/4. And negative 11/4. Sorry again for my voice. I hope you're able to follow along okay with me. Thank you.